solve some more trigonometric equation. 2 sine squared x equals 2 plus cosine x. Now again, we have two different trig functions. You need to change them into the same trig function. Now, which one is easier to change? Is there anything I can do with the cosine to write it in terms of sine? No, not really. So what I'm going to do is I'm going to change the sine squared, and I'm using the Pythagorean identity. So 2 times, instead of sine squared is 1 minus cosine squared, look, equals 2 plus cosine x. So now we have at least cosines on either side. Okay, what do we do next? Let's distribute. 2 times 1 is 2. 2 minus, we're multiplying by cosine squared, so 2 cosine squared x equals 2 plus cosine x. Now, when I see something squared, that reminds me of a trinomial, of a quadratic function, quadratic equation in the form of ax squared plus bx plus c equals 0. So that's exactly what I want to do now. I want to set this equal to 0, and I want to keep the cosine squared term positive, which means the left-hand side has to go over to the right-hand side by doing the opposite. Minus 2 and a plus 2 cosine squared x. So I do the same on the right-hand side. Let me write it minus 2 plus 2 cosine squared x, and let's see what happens. I write the cosine squared first, just like I do with our quadratic equation, in descending order with the exponent, so 2 cosine squared x. And then we have plus cosine of x, and we can see that the plus 2 and the minus 2 cancel out, so that is equal to 0. Now, where do I write the 0? Doesn't really matter. Okay, so this is now what I'm dealt with that I have to solve. And factoring would be the method of choice here. We factor out the greatest common factor. The greatest common factor is the cosine of x. And then I have left 2 cosine of x plus, don't forget, if you divide the cosine into the cosine, that is a 1. So I have 2 factors here, and just like in algebra, we're going to set each factor equal to 0 and see what happens. So the cosine x is 1 factor. We set that equal to 0, and then we have 2 cosine x plus 1, and we set this equal to 0 as well. Now here we have a restriction. We have a restriction that we're looking at our domain from 0 to 2 pi. So let's work with the cosine x equals 0 first. When is the cosine, for which angle is the cosine equal to 0? Now, if you look at your unit circle or you look at your general cosine graph, the cosine is equal to 0. X equals at pi over 2. When else is the cosine equal to 0? The cosine is equal to 0 right here, which is, in this case, 3 pi over 2. So you solve cosine of x equals 0, you find the angles. Now let's look at the second factor. Let me write it down here. We have 2 cosine x plus 1 equals 0. So the next step would be to isolate the cosine by subtracting the 1 dividing by 2. So the cosine of x in this case is negative 1/2. For which angle is the cosine negative 1/2? Well, the cosine is negative 1/2 in quadrant 2 and in quadrant 3. So in quadrant 2, the angle is 2 pi over 3, and in quadrant 3, the angle would be 4 pi over 3. So our solution to this problem, we have 4 angles here, pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Done you are. Great.